Okay. Well, man, I don't know what is better to you in this moment, but if you ask ask you with your if you ask your teacher in school, I suppose it's better to him help you with this book problem. Okay, so speak with him. I suppose in your school have some English book in the library,
Yeah,
so you
it's
can.
fine.
Right?
It's fine that it's Portuguese. That's better for me because in the quiz it won't be in English.
Okay, but uh, do they have a English book in the library?
And no, they have
No.
English books, but not physics.
Oh, I suppose. You can try in Amazon, for example. Amazon, but you need to use the Amazon, Spanish Amazon, for example. Let me see. Physics. For example, this book's interesting. Physics is high school. Physics is Cambridge. It's very, it's very cheap. Okay.
Yeah,
Any one of this is interesting to you, but I don't know this first one. Let me see. Physics workbook. Okay. Seems to me is English, but have a lot of Italians commenting here. But I suppose it's English, international. So English edition. 23 euros. Is very cheap. Okay.
yeah,
But I suppose you can get a download today if you try. Okay. But try to do this today. If you don't get a book, I search to you. Okay.
yeah. Okay.
So let's go to the 26. I will translate this. I will translate this. Okay. Uh, okay. Let me see. A racket. A racket. A racket. Hit in a tennis ball. 0.5 meters off the ground. Put in this a velocity of 20 meters per second in an angle of 15 degrees with the by the horizontal. The ball moves in a perpendicular plane with the web. The net is better. That has 1 meter of height and is 20 meters of the launch point. Search if the ball throw or not of the net. I suppose this is the problem. Do you understand the problem?
Yeah.
Did you understand?
Yeah.
Yeah. So it's a little problem of, again, bidimensional move. Okay. Bidimensional move again. So again, you need to use that equations. Okay. Just it. So again, we need to do the draw the graph of the problem. I will do this here. I will take a better translation of this. Oh my god. Oh my god, this is very bad. I suppose my translation is better because don't have problems with the form with a right like this.
Yeah.
50 here. But okay, do you understand the problem? This is the
Yeah.
important to me. If you have problems, just tell me. But again, we have a situation. Oh my God, we have a situation, this kind of situation. But I don't know if the ball will pass to the net because the net can be more high. The more high than the ball in this position, the position of the net. So I don't know this position here, for example, the position of the net. The problem said the net is 20 meters to the launch point. So we have here 20 meters, okay? Just it. And we have another information. Um, the um, the ball is launched 1 meter off the ground. So the move starts something like that, I suppose. And this is 1 meter. The tennis ball have few than 1 meter. So I really don't know what's the ball moves in a perpendicular plane with the net perpendicular plane. So I suppose it's this, but this is really this is a little strange because I don't know if the move is this kind of angle. We have an angle. We have an angle, but a little angle, just 15 degrees. So it's something like this, okay? Here we have 15 degrees, okay? So I suppose it's the draw of the movie, the draw of the situation. Okay, so what's the problem here? We need to know what's the position of this ball in this position. What's the y position, the vertical position in this point? Okay, in this point. So we need to look this. How can I understand what is the position here? Because if the ball has a height fewer than the height of the net, the ball will not pass. Okay, but if the height of the ball is greater than the height of the net, the ball will pass. Okay? So I need to know what is the height in this position here. Just it. So I don't know. How can I do this with the equations? Let's go to do this, because we have the velocity, and I teach to you how to get the velocities, the components y and x, the velocities. Okay? The x component is v cosine of the angle, and the velocity in y, the vertical velocity, is v sine. Okay? Everything all right?
Yeah.
No problem. You are I'm not sure, but okay. So it's interesting to know what's the time here. Because if I know what's the time here, I just put this time in the position equation, and okay. Because if I need to know the position y-axis, you can remember this equation here. Did you remember this equation? We saw this a lot of times. I suppose you remember.
Yeah.
Okay. And we have a lot of informations. If this is the equation of the ball, so we know a lot of things of the ball. For example, the initial position y is 1 meter, because here is 1 meter. What's the velocity? The initial velocity is just 20 cosine of 15 degrees. Okay?
Yeah.
And if we have acceleration, the gravity acceleration, we know this is 10. But to verify the height, I need to know y, so I need to know t to put in this equation and get y. Okay? So I don't know how much cosine of 15, but I will put this in a calculator. In my calculator, this is 0.97. 0.97. So 0.97 times 20 is 90.3. 90.3. 1 plus 90.3 times t minus 5t squared. So what can I do here? I don't know the time. I don't know. So I need to know. So how we can get the time? Do you know how we can get this time? The time where the ball arrive in this position? Do you know? For now, we just use the y equation. We can use the x equation, right? Because we know the development. Now we know the range is 20 meters, and we know the velocity, and we know the equation. X equals basically v0x times t. So you have this, and you have the, oh my God, and we have this here too. You need to put these values in these places and get the value of t, okay? So when you get the value of t, you put this t in the another equation and get the value of the height, okay? Can you try this for me? If you try, send me a photo and I do the corrections, okay?
Okay, so I replace x with 20 v0x is v cosine theta.
Yeah, x is 20, perfect. And
Theta
V0 is
is
V cosine theta. Yeah, perfect. The velocity is 20. And the cosine of, oh my God, I suppose I do an error here in my count, but you can do your count. I do an error here, but it's not a problem to you. It's just a problem to me. You can do your math. This is wrong to me because here is sine. Cosine is to you, sine is for me. I wrong here. I was wrong. But okay, you can use the cosine. Man, I really need to go to bathroom. So you need to try this, okay? You can read the problem again and you need to try. Okay, I go to the bathroom and I come back soon. So, did you do something?
Yeah, I'm still not finished.
Okay. When you finish, just send me a photo. Okay.
Okay. I'm getting something weird. It would so for the Vx equals V cosine theta, it's going to be V 20 multiplied cosine 15.
Cosine 15, yeah. So, how much?
It'll be 5 root 6 plus 5 root 2.
No. I suppose you don't need to use this form of the cosine of 50. You can use the decimal form. If you put in your calculator, for example,
So 19.3.
yeah,
Okay.
0.99. Yeah, 0.9, I suppose. 0.96.
0.96. Okay. So 20 times 0.96.
Yeah. So you use this.
And by the way, how do I convert it to decimal?
How can you convert to
Uh,
decimal?
like how did you convert cosine theta to
You don't.
0.96?
It's not this kind of math. You just put this value in the calculator and finish. Just it. In physics, you don't need to know the values of the cosines and sines. You just use your calculator. Do you understand?
Yeah.
So it's only put in your calculator.
And in that formula, we're finding the time, right?
Yeah, if you put these values in the red equation, you get the time. So you take this time and put this in the equation of the height, this equation here, to know the height in the position of the net. Okay?
Yeah.
Okay.
Thank you, my answer.
Seems you do something so right. You have the time. Okay, so now you just put this value in the y equation and send to me the value of the y-axis position.
Okay. and the and why it's going to be in meters, right?
Yeah.
Okay.
Let me see. You send me something.
Yeah.
You put the values in the equation. So you do some math and you get the value 0.96, 0.97 to round. Well, the net has a height of 0.5 meters, right? So the ball will pass the net. Okay?
Yeah.
This problem is just a real problem, a real physics problem in the real world. So it's very interesting to you understand and get the do the mathematization of this real problem. Okay, but you will not do you will not get do this if you don't do the draws, the graphs of the problem. You need to draw more in your problems, okay? To understand what's doing. Okay, because this is not a real hard problem, I suppose. But you need to try more. I will start the problem 27, but you need to do the problem. Okay, you have the another problems to use like examples, and you can ask to me anything, but you need to try. I will translate this if you have problem with my translation, you can put this in your Google translation. But I will write this. Just a second, because my English is not the best, do you know? But okay, let's go. A soccer player, my God, a soccer player hits 20 centimeters off the ground a ball with a velocity of 20 meters per second, doing an angle of 16 degrees with the horizontal in a direction with a goal where that the bar. This is a Portuguese word because I am Brazilian. And I suppose this is speaking about the goal of the soccer play. I don't know this. In Brazil we use another word to do this, but it's the upper side of the goal. Okay,
Yeah.
upper side is 24 meters of height. The distance of the player to the goal is 20 meters. Verify if this will be a goal. Goal, the goal, the really goal, the situation when the ball pass the goal. Okay.
Yeah.
This is what they wanna do. Okay. Muy bien. Let me see. Let me see. We need to draw this again, okay? You need to draw this again, but I will need to draw this in this time. You will draw. I will send to you this. The draw will be very similar to the last question, very similar. So you can, I wanna you try this time, okay?
Okay.
I will send to you just a second. So in this first time, I just wanna a draw, okay? Do a draw, a big draw, with a lot of vectors and stuff, okay? The draw will be very similar at my draw, okay? So when you do, send me a photo.
I sent you my drawing.
Let me see. Yeah, amazing. Your draw is cool. Your draw is very cool. Okay, this is a really good draw. So the problem is very similar. What problem we did? So I suppose you can do this alone. So you try this today, and tomorrow we have a class, and you send to me what you do. Okay?
Yeah.
So is this, man? Very cool, very cool. So try to buy a book, and we talk tomorrow, right?
Yeah.
Okay,
Okay.
bye-bye.
Bye. See you.